In this video, we're going to be looking at some examples of modeling a launched object. So for number 1, it says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. Part A says, how long is the ball in the air? We'll round our answer to the nearest hundredth if necessary. So first I see, since it is being tossed, it's not being dropped, we're going to be using that formula h is equal to negative 16t squared plus v naught t plus h naught. I want to find the time the ball is in the air, so I'm looking for my value of t. And so I need to fill in what my height is, my initial vertical velocity, and what my initial height is. So reading through the problem, I see that the ball leaves the juggler's hand 4 feet above the ground. So it starts at that 4 feet. So that's my h naught. And then it says the initial vertical velocity is 30 feet per second. So that's my v naught. And I want to know when the juggler catches the ball when it falls back to a height of 3 feet. And so that's going to be my h. So I have h is equal to 3, v naught is equal to 30, and h naught is equal to 4. So I'm going to plug that into my formula here. And so when I plug it in, h is equal to 3, so I have 3 is equal to negative 16t squared plus v naught, which is 30t, plus h naught, which is 4. And I want to solve this for t, and I see I have a quadratic function here. And so I know I can use the quadratic formula to go ahead and solve this. However, it's not in standard form yet because I have this equals to 3, so I'm going to go ahead and subtract 3 to the other side first. And so now I have 0 is equal to negative 16t squared plus 30t plus 1. And now I can go ahead and use the quadratic formula. So I'm going to label my A, B, and C. And remember, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So plugging those in, I get that t is equal to negative b, so negative 30, plus or minus the square root of 30 squared, minus 4 times negative 16 times 1, all over 2 times a. And so simplifying in the top here, I get negative 30 plus or minus 30 squared minus 4 times negative 16 times 1. I get 964 all over 2 times negative 16, which is negative 32. And now I can go ahead and split that since I have that plus or minus. So this is going to be equal to negative 30 plus the square root of 964 over negative 32, and negative 30 minus the square root of 964 divided by negative 32. And I can go ahead and find those values in Desmos. So I want to go to desmos.com. And I'm going to plug those in. And so I have negative 30. I'm going to hit the division sign to go ahead and get that fraction. And then do plus square root of 964 all over negative 32. And so I see I get negative 0.03 for that first one. And then I'm just going to change this plus to a minus. And I get 1.91 when I round to the nearest hundredth. And so I see I get two different answers there, but I'm looking for just one, and I want to know how long the ball is in the air. Well, I can't have negative seconds, so that means the ball is going to be in the air for 1.91 seconds. Okay, and then part B says, what is the maximum height of the ball? Round the answer to the nearest hundredth. Well, we learned about in our previous unit that maximum height, that is where our vertex is. And for height, that is our y value. And so for this one, I need to find my vertex. So I need to first find my x-coordinate of the vertex and then plug that back into my function to figure out what my y value is to find the height. And so remember that the x value is going to be the opposite of b over 2a. And here my function, again, was, let's write it over here, h equals negative 16t squared plus 30t plus 4. So that means that my b is 30, so the opposite of b is equal to negative 30 over 2 times a, which is negative 16. So it's going to be negative 30 over negative 32. And if I were to go ahead and simplify that, I can take a 3 out, not 3, I can take 2 out and I get negative 15, or 15 over 16. And so now I can find my y value at that point, or in this case h. And so I can find that by plugging in 15 over 16 for t. So I get negative 16 times 15 over 16 squared plus 30 times 15 over 16 plus 4. And you can go ahead and use Desmos for this again. So I'm going to do it here. So I have negative 16 times 15 divided by 16 squared plus 30 times 15 divided by 16 plus 4. And so I get that this is going to be approximately 18.06 feet. Oops. Okay, let's look at another problem. So number 2 says a geyser sends a stream of boiling water up from the ground. The water has an initial vertical velocity of 130 feet per second. How long is the water in the air? Okay, so this one is, again, a launched object, so I know that my formula is h equals negative 16t squared plus v naught t plus h naught. So I need to figure out what my h is, my v naught, and my h naught. Here I see that it is sending a stream of boiling water up from the ground. And so that means my starting height is going to be x, or h naught equals 0, since I'm starting from the ground. And then it also says the initial vertical velocity is 130 feet per second. And so that is going to be my v naught. And the first question asks how long is the water in the air? And so we're looking at the full thing, and so it shoots up from the ground and then comes back to the ground. And so my ending height is also 0. And so plugging that into my function here, I have that 0 is equal to negative 16t squared plus v naught, which is 130t, plus h naught, which is 0. However, if I add 0, I just get what I have, so I can erase that plus 0 at the end. And I'm going to solve this. So you could solve this using the quadratic formula. However, an easier way is to go ahead and factor using the GCF. And so if I factor this, I can go ahead and take out a negative 2t. And when I do that, I'm left with 8t minus 65. And so now I can use my zero product property, and that is that negative 2t equals 0, or 8t minus 65 is equal to 0. Well, when I solve this first one, I just get that t is equal to 0. And we know that's not going to be the answer because the water was definitely in the air for longer than 0 seconds, so that's not my answer. And so I know my answer is actually going to come from this second equation. And so when I divide 65 by 8, I get that t is equal to 8.13. So the answer here is that the water is in the air for 8.13 seconds. So part B says, when is the water 100 feet above the ground? And then we're going to round our answer. So now we have a different height. We have a height of 100 feet above the ground. So we have a new h value. So now h is equal to 100 instead of the 0. And so plugging that into my function, I now have that 100 is equal to negative 16t squared plus 130t. And so now we can go ahead and solve this with the quadratic formula. I need to have it in standard form first. So I'm going to subtract 100 from both sides. And so I get that 0 is equal to negative 16t squared plus 130t minus 100. And now I can go ahead and label my a, b, and c. So my a is negative 16, my b is 130, and my c is negative 100. And so I get that t is equal to negative b, so negative 130, plus or minus the square root of 130 squared, minus 4 times a, which is negative 16, times c, which is negative 100, all over 2 times a, which is negative 16. Simplifying that out, I get that inside my radical, I have 10,500. And this is going to be over negative 32. And now I can go ahead and split this apart. And so my two answers are going to be negative 30 plus the square root of 10,500 over negative 32. And negative 130 minus 10,500 over negative 32. And so if you go over to Desmos and calculate that first one, you should get that this is equal to 0.86. And then again, when you go in there and now instead have minus, you should get 7.26. And so this one's actually going to have two answers. We see that the water is 100 feet above the ground at 0.8 seconds and 7.26 seconds. Which makes sense since the geyser is starting at the ground here and shooting up the water. We see at 100 feet it's going to happen in two different places.